In the last episode, we discussed a few facts about a chemical reaction. This time, we're going to take a final look at a chemical reaction, and we are going to focus on the coefficients on a chemical reaction. After this, we will be ready to move on to our next topic, which is the calculation based on a chemical reaction. All right, looking at the reaction in front of you, what does the coefficients tell you? Well, there are two ways to look at it. Number one, the coefficients tells us every one molecule of ethanol, C2H5OH, is ethanol. Every one molecule of ethanol can react with 3 molecules of oxygen, and they will produce 2 molecules of carbon dioxide and 3 molecules of water. This is looking at the reaction at the molecular level, which we call it microscopic level. We can also look at the reaction at a macroscopic level, which is molar level. At a macroscopic level, this reaction tells us every 1 mole of ethanol can react with 3 moles of oxygen, and they will produce 2 moles of carbon dioxide and 3 moles of water. If that is the case, then coefficients can be used to generate conversion factors. What does that mean? For example, if you focus on the ethanol and the products, this reaction tells you if 1 mole of ethanol completely reacts, it will produce 2 moles of carbon dioxide and 3 moles of water. Talking about the molar relationship between ethanol and carbon dioxide, or ethanol and water, there are different ways to write them. The first one tells you the relationship, the molar relationship between ethanol and carbon dioxide. Every 1 mole can produce 2 moles of carbon dioxide. To produce 2 moles of carbon dioxide, you need 1 mole of ethanol. Either way you look at it, you know that any conversion factor can be written in 2 different ways. So the first 2 tells you the relationship, the molar relationship between ethanol and carbon dioxide. The second row tells you the 2 ways for you to specify the molar relationship between ethanol and water. As a matter of fact, you can write out the molar relationship or the molar ratios between any 2 substances in the reaction. Here is another example focusing on the relationship between ethanol and oxygen. Every 1 mole of ethanol will react with 3 moles of oxygen. Again, there are 2 different ways to write the conversion factor. Depending which one is given, which one is wanted, you choose 1 of the 2. All right, now with this flow chart, can you visualize that given information of any one substance in the reaction, you can calculate the information of any other ones in the reaction? For example, let's say someone is planning to do this reaction, and that person knows that I have certain grams of ethanol. You have certain grams of ethanol available. You want to perform this reaction to react all the ethanol you have, and you want to know how many grams of water it can produce. Assume that is your question. Well, let's map your question to the flow chart. We know grams of something. We know grams of ethanol. Wanted information is how many grams of water will be produced, grams of something else. So that is the question, grams of water. B is water, A is ethanol. Well, with this flow chart, we know that once you know grams of ethanol, you can calculate the moles of ethanol you have. from moles of ethanol by using the equation coefficient. You can convert moles of ethanol to moles of water. Every 1 mole of ethanol will produce 3 moles of water. The conversion factor was provided on the last slide. We saw that. Regardless what it is, it could be in other different ratios, but you can use the coefficients to know the molar relationship between ethanol and water. So using the equation coefficient, you can convert moles of ethanol to moles of water. Once you get moles of water, you can get grams of water by using the molar mass of water. Good. That will be the topic of our next episode.